Yes, now we are entering the interesting aspect of our presentation. So we just quickly run through, right? So you can see this is the robot which we just discussed. So I'm just going to skip through this. And what you're seeing here, you might have seen this video, right? So this is a snake robot. Okay, you can see this is a snake robot which is going to swimming around. It's created in Japan. It's used for underwater exploration and also for disaster response. So when there was some Fukushima during yes, there was a disaster, right? So at that time they used these kinds of robots to explore because man could not go there due to the nuclear radiation. So they used different types of robots. This is also one type of robot which they used, and this is a robot which has the human-like dexterity, and it is very safe to work around people. So this is nothing but a collaborative robot. Okay, you can just quickly run through. I'm just going to go fast here. You can quickly see all this, which country, which year, and all that. And I would like to guide you to this particular website. So robots.ieee.org. Okay, please go there. It's for all people, for all ages, even school children, even kindergarten children can have a look at that. And even us, there are hundreds of robots listed in that. Robots which are available now. So all the slides are taken from robots.ieee. So this is a collaborative robot. So just have a look at the picture and just we'll have one takeaway from that picture. Okay, that's how we are going to go. So this is a threaded. You can see some threads. So obviously it can navigate some hazardous environments, even rocks and some slushy environments and all that. And so this is used to locate, inspect, and remove some dangerous materials. Maybe a bomb. Okay, it can defuse a bomb. So it's used in military, even in industry also. This is again, it's another collaborative robot by Universal Robots. So collaborative robots are designed to collaborative robots are shortly called as cobots. COBOTS, cobots. So they share workspace with a human being. Okay, so such robots must have their own characteristics. I mean, the human must not get damaged. So they must have sensors to detect that there's a human adjacent to that person. Okay, and it must be user friendly. Human must be able to do some signals so that it can sense and it does it. It must wait for the human being. So it has its own characteristics. So we'll be seeing. So this is another collaborative robot, and it has 2 arms. So this is what you're going to be seeing a short simulation now. So it's called Yumi. Okay, it's by ABB. So it's a collaborative robot. You can see a person and the robot are doing a task together. And it also has 2 arms, kind of like our conventional robotic arm, which is just 1 arm. It has 2 arms. So you can see it just lacks a head. Okay, you can give a head and it looks very, very much like a human being. Okay, so this is from Switzerland, by the ABB company. And Titan, this is the world's strongest robot. It can lift over a ton. Okay, so it can, like here you can see in the picture, is actually lifting a car. Maybe it's not fully assembled, but still, it's still heavy. So this is from KUKA. It's a manufacturer from Germany. And yeah, so just now we were talking. So now it has a head and 1 arm. So this is called Sawyer. This is by Rethink Robotics. So it has a screen, okay, where it can change its emotions. It can look, it can smile, it can do all that. And you can, on top of the screen here, you can see there's a camera. Okay, can you see here? Now this is the world's smallest 6-axis industrial robotic arm. So this is by Academic. And this is also from KUKA. So it has 7 axis. So 7 axis means it has 7 degrees of freedom. And this is an interesting robot. Here you can see, so it has these wheels, more like pulleys, okay, which can travel on these cables. So this can inspect there any damage done to the high voltage power lines. So it can inspect up to some 500 kilowatts. It doesn't get damaged because of that. So it has been designed in such a way, okay, and it can also repair it. So in case if it senses that there is some damage, it can also just repair it. So this is a very dangerous task for human being. Now this explainer is capable of automating that task. We also have some quadcopters which is doing the same thing. But quadcopters, they mostly sense it and they return, so that somebody can go and repair it. But this, it senses it can also repair it. And this is a snake arm. It resembles a snake-like, so it's capable of that sinusoidal actuation. Okay, so such robots are also being used in robotic surgery. I'll try to discuss in the coming slides. So we have adaptive gripper, no matter what you want to grip. So this is a very simple 3-jawed gripper which is capable of gripping different types of objects. And this Aquanaut is nothing, it's a transformer kind of, I'm sure all of you have seen the Transformer movie. It's a transformer kind of underwater vehicle. So its arms just tucks in. So it looks like some underwater vehicle, like a submarine kind of a thing. Then when it wants to actuate on some maybe repair something, repair a ship by going underground or something like that, its 2 arms pop up and it can do actuation. And it also has camera, lighting, everything. So this is by Houston Mechatronics. And Tiago, it's an indoor robot. It's a service robot. So it can interact, maybe it can even be used in hospitals where it can act like a robotic nurse. There are many tasks which you can do. And TALOS, it's a humanoid robot, so it can work in an industry setting. So these robots are working in industry. So it's doing a task which human beings do, especially if the environment is very dangerous. Maybe there's a radiation or the temperature is very high, something like that. And yeah, so it's a very interesting one. So a very revolutionary company called Boston Dynamics. So Boston Dynamics, they have this four-legged robot which is inspired from a dog actually. So this is called a Spot, and you can see instead of a head, it is having a robotic arm. Okay, so it's a combination of a mobile robot and a robotic arm. It's very interesting to see these things in action. Okay, there are many videos in YouTube. You can have a look at that. And this is a shadow hand, which is inspired from our own hand. This is a parallel robot. So mostly we were seeing serial robot, right? Here you can see parallel robot. So parallel robot means you have links which are parallel to each other, right? There we had links which are connected in series. Here you can see, so this is one joint. So you have 1, 2, 3. Okay, so you have at least 3 links here which are jointed at the same joint. So these types of robots are called as parallel robots. So the inverse kinematics is somewhat a little bit more complicated than our conventional serial robots, but such robots are also available in most of the shop floor nowadays. So these are nothing but mobile autonomous robots. So such robots are also used in industry nowadays. So this is by Invaya Robotics. So you can see they are autonomous. They have wheels, so they can move around in a warehouse, and they also have this a crane kind of a thing where it can lift to a particular rack. I'm sure you're able to see here, right? So it has a small actuation device here which can push the box to the rack. So it can go somewhere, it can raise to that particular level, and it just pushes the box. Sometimes it also some vacuum cups which can also pull in some boxes, and it can come. So mostly in automated storage and retrieval systems, okay, such robots are being used. So this is a similar robot which is called Otto, and a similar factory robot. Yeah, and this is even in agriculture, robots are being used very widely. So Harvest Automation is a company which is working on that particular segment. Okay, so this robot, it's very cute looking and simple looking robot with approachable appearance. Here you can see it can just lift that pot and you can move it somewhere else. Okay, depending, you can monitor and you can transport it somewhere else. Okay, maybe it can air it, put it in for some time, and then you can put it inside. You can do all of those tasks. It's a humanoid robot, a very advanced humanoid robot from Japan. Again, a four-legged robot. And there's another very interesting robot called Handle. So it has only 2 wheels, if you can see at the bottom, and it has a counterweight. You are able to see here, right? This is a counterweight. So it's using this counterweight that it is balancing. Okay, so it's a wheel, and see, just look at the amount of control that is there in this particular robot, right? So if it's going to lift this weight, it's not going to topple, right? So depending on what weight it is going to lift, immediately it's going to move its counterweight in the opposite direction so that it can balance all the time. That is, it's balancing on just 2 wheels. Okay, it doesn't have 3 wheels. Okay, it just have 2 wheels. So the amount of dynamics that is involved. So this is also by Boston Dynamics. There's another snake type of robot which is capable of climbing stairs. And you have this robot is a very large scale industrial exoskeleton. That is, you can see a man is wearing this exoskeleton. So he can move and he can also see. So he can move and he can. So when he moves, this motion is duplicated into this robot. Okay, and this robot is doing it. So Fetch is another mobile manipulation platform. So this can be used in supermarkets. And this is a flying robot. You can see the rotors here. Okay, so this cage is just for its own protection. So this is just flying around just to see whether there are any cracks or any damages in this tank or even boilers, pressure vessels. Okay, so such robots are being used even in India nowadays. Okay, so drones are being used to inspect oil pipelines, etc., etc. And this is another digit. It's a humanoid robot. Once again, this is by Agility Robotics. It's doing a package delivery. So you can see it's endless, right? And this is a very famous robot, Baxter robot, very similar to Yumi, but it has a face. Actually, it's an expansion of the Sawyer robot, which we just saw, which had only one arm. Now it has both the arms. So it just keeps on going, right? Now you can just see here. So this is also by Boston Dynamics. So this is the first type of humanoid robot which we can soon hope to see even on our roads, in our shop floor, because the level of control, it looks just like a human movement, able to jump through the obstacles and lift objects just like a human being. It's another 4-legged robot. It's another aqua robot which can swim underwater. So the robots which you're seeing here, they're from all over the world. Some are from Canada, some are from China, some are from Germany, and they look differently, right? Now look, I'm sure all of you have seen a 3D printer. So 3D printer is also a robot. So robot it's nothing but it has an extruder as an end effector. That's it. So a welding robot may have a welding gun as the end effector, but this has a extruder as the end effector. That's the only difference. Now let me show you a small peep into the software. So I'm not, I think due to shortage of time, we're not going to see much. So let me just give you a short peep. After that, we will immediately go to discussing about the robotic careers. So I'm just showing you a peep. Okay. See, there are lots of robotic simulation software out there. There are many, and you have many open source softwares which are there. ROS, robot operating system, and Gazebo, and you have MATLAB. You have MATLAB is a very widely used software, mainly because of its versatility, and it's been there for a long time. And many companies use MATLAB, and MATLAB has a toolbox called Robotics Toolbox, a toolbox which is exclusively for robotics. So that has been created by a pioneer called Peter Cork. So MATLAB Toolbox is nothing but the PhD thesis of Peter Cork. So he worked in robotics and vision-based control of robots. So that was made as a robotic toolbox, and he is the one who is maintaining the toolbox even now. And he's also I think the editor for a very famous robotics magazine. So what you're seeing here is nothing but your ABB Yumi robot. So here you can see, so you have different links, and you have two arms here. So here you can see, this is the MATLAB environment. So MATLAB robotic system toolbox, it has lots of robots in it. So you can load the robot or able to see the code. So here you can see I'm loading a robot called ABB Yumi, right? And I'm setting the gravity as minus 9.81, just like our own world, right? Minus means negative y-axis, that is negative vertical direction, and the magnitude is 9.81 meter per second square. So we use something called interactive rigid body tree for constructing this robot, right? So this is the robot which it's already there, okay? And and you have many other configurations also. So what you can do is, if you're going to do doing some research on the inverse kinematics of this particular robot, or just to see whether the algorithm, maybe you could be from computer science background, and if you have created a algorithm, a machine learning algorithm, and you want to see whether that machine learning algorithm helps this robot to do the particular tasks easily, so this ready-made platform can be used. And of course, people from mechanical domain can also do all this machine learning for some sorting. Maybe you can even simulate a conveyor belt. You can study the response. You can study how the operation is done. So such ready-made robot models can help you. Okay, that is, you can also create your own models. Okay, you can create the models from scratch. You can create your own robots also in this platform. But you can also use the platforms which are already there. So we're not going into the detail of this. So we are creating the other objects. Here you can see there's a plane, there's a box and all that. So we use a function called collision box to create all that. So we have two manipulators here, 1 and 2. You can interactively move them. So I'm trying to move the arm in a trajectory, because whatever task you want it to do, it has to move, correct? It has to pick up an object and it has to move, and it has to put it somewhere else. So that movement is called as that the path which is traced during that movement is called as trajectory. So you can control it to any trajectory. Let me just run this, okay, so that we can have a look. So now if you look closely, so you can see that the arm is moving. Can you see here? So the arm is moving there. So this movement is based on the trajectory which we have given. Under this robotics toolbox, we have functions for everything. Okay, we have functions to load the robot. We have functions to define the trajectory. We have functions to set the environment, like you can change the gravity. You can control the force. You can give the weight for the objects which you're lifting, because depending on the weight which is lifting, the torque that is experienced by the robot in its joints will change. Okay, so there are a lot of things are there. And if a robotic arm is at an extended position, now if you just look at yourself, you can lift a heavy bucket when your arm is closer to your body, but you'll not be able to lift the same bucket, when your arm is extended, right? When your arm is extended, automatically the weight which you can carry is going to be decreased, right? So the same concept is here. That's why I said, right? Most of the concepts you can just you are doing it every day. You're experiencing it every day, so you can easily understand that. It's a very interesting platform, and not only industrial robots, but also mobile robots. Mobile robots can also be simulated here. Okay, and you can even do a co-simulation with other software. Okay, there is Gazebo simulator. Okay, due to lack of time, I'm not showing it here. Which is actually Linux based. It gets installed in Linux, so you can have a virtual box no matter what OS you have. Okay, you can have virtual box and you can install that ROS and the Gazebo. So my MATLAB can interact with Gazebo. You can simulate a robot in that particular environment, right? It has more graphics and it has more, you can have quadcopters and all that. Even here you can have quadcopters. Quadcopters can also be simulated here. Okay, and since this has this coding platform, okay, and these functions, fundamental functions, you just have to imagine a robot, just think up of a new application, imagine a robot, design it using what we saw, right? The Dynamite-Hartenberg representation and all that. Okay, just design the kinematics part and the dynamics part. Okay, and you can just code it. You can use these functions. You can visualize it. Okay, you can simulate it, right? And then You can even, MATLAB has an option where you can just transfer the code. You don't have to code the hardware separately. Whatever hardware you are using, maybe it's Arduino based, maybe it's Raspberry Pi based, or maybe something else. Okay, it automatically generates the code. You just can copy the code to the hardware, and the hardware automatically repeats the same way you're doing simulation. That's the use of simulation, right? Okay, if you're doubtful of something, before putting it in the actual hardware, you can just do it in the software, because if something goes in software, it doesn't matter. But if the same thing happens in the hardware, definitely a robotic hardware is going to be very costly. So that's the main objective of the simulation. So I just wanted to show you a glimpse into this software. Maybe you can have a look at this. You can explore this on your own. You can just go to Google and you can have a look at even other software which I was just telling about. Many open source softwares. ROS is open source, Gazebo is open source, and you can do a co-simulation with even other software. Like there's another software called CopiliaSim. Okay, even MATLAB can do a co-simulation with software called CopiliaSim. It used to be called VREP, Virtual Robotics Experimentation Platform. Now the name has been changed to CopiliaSim. Even that is a very good platform. And mostly we interact with the MATLAB. Why MATLAB is because, see, MATLAB also has other apps. Okay, so here I can see I have an app called a Deep Network Designer. Okay, so if I want to do deep learning in my ABB Umi robot, so all I have to do is use that also. So that deep network, there is a toolbox. It also has its own functions. So I can make use of all the functions in the same platform. So in this platform, I can create a robot. Then I can use this deep learning. I can use a network, maybe an already existing neural network, or I can create my own neural networks. And I can do a deep learning analysis on it. I can make a robot vision. Due to the lot of availability of toolboxes, and due to the versatility, and due to the multidisciplinary research which you can do on this platform, MATLAB has been a very famous one. And it also interacts with other open source software. So that's another advantage. That's just a small glimpse which I wanted to show you, just to give you a feel of how, as a robotic engineer, or as a developer, as a robotic software developer, you'll be able to, what you'll be experiencing. So now outside industrial setting also, we have lots of, so what technology has been found for the industry, now it's being used everywhere. So you have prosthetics, so life hand is a prosthetic that is used by human beings. So nowadays, even Elon Musk, they have come up with something called Neuralink. So you can put a chip in your brain, and that brain helps you to interact with your prosthetics. So lot of things are happening nowadays, and this is what I was talking about. So even in robotic surgery, right? So here the workpiece is the human body. So the human body, there's something called minimally invasive surgery, right? So they use all of these robotics. So Da Vinci is a very famous robot which is used for surgery, and you also have these flexible robots, right? The one which you're seeing, snake-type robots which are being used nowadays, and we just saw it, right? We have some military applications. It can be used everywhere, even in space. So this whole space station, right, that can be called as a manipulator. So it just moves around, carrying this astronaut, or maybe some other package also around. And so this is very interesting. So you can see this has been inspired from octopus. So you can see this portion looks just like an octopus. So this is called a tentacle gripper. This is Festo. So you can go and see Festo also. So Festo also have made a lot of robots which are inspired from nature, butterfly-like robots. Lots of very interesting videos you can find in their website. So there's another company which you need to follow, Festo. And yeah, you can see, as I told you, you can use smart materials and 3D print a small gripper like this. Okay, so you can see. So once you give heat, it changes shape. So a 4D printed structure is nothing but, okay, once you give some stimulus like heat or electricity or something, it changes its shape or some other property also. That is also called 4D printing. But when it changes shape, that can be used as a gripper. Here you can see, right? So you can, this is heated actually. So you can give heat, it grabs, then you can move somewhere else. So such things are even nowadays people are thinking to use them inside human body in stents and angioplasty, some certain surgeries also, certain procedures also. They're thinking of using the 4D printed structures. Now machine learning and artificial intelligence is exploding everywhere. Everywhere you go, in LinkedIn and every social platform, they're talking about machine learning, artificial intelligence. A lot of people are giving it's being democratized nowadays, right? A lot of people are giving a lot of courses, and it's accessible to everybody. Okay, Python is accessible, and its packages are accessible. Okay, and it's exploding. So this is nothing but Google's AlphaGo. It's very famous actually. So AlphaGo, Go is a game. So the picture you're seeing the human champion, who is a champion in Go, and Google's AlphaGo, it defeated the champion. So we have gone to, here they use something called reinforcement learning, which is used in robotics all the time. So where the robot learns by, just like how we learn. Okay, we make a mistake, we learn that we should not do it, right? We make something, we get some reward for doing something, then it gets positively reinforced, we continue doing it. So this is called reinforcement learning, and that is used here, okay, in AlphaGo. So it learned by studying a lot of games, and it learned by playing with itself. It ran a lot of scenario in its brain. It used all of that experience to defeat the world champion. So it is exploding like anything. So definitely, whatever growth that is going to come in machine learning and artificial intelligence, that is going to directly impact the robotics, any kind of robotic subfield. Now, if you look at this, is called as hype cycle, which is released by Gartner every year under the different headings. So this is called for emerging technologies. So I'm just both are same actually. So right side, this is the most zoomed version. So why I wanted to have this is, so impact on robotics field. If you look at every aspect, so we're not going in detail into every aspect. Here you have some two-way BMI, brain-machine interface, the one which I was talking, right? So you put a chip in your brain. So it's two-way interaction. So brain can interact with the chip can interact with the brain. So that and self-supervised learning, I can see anything, okay, augmented development, so a digital twin. So any field, any emerging technology has influence on the robotics field. Okay, that's the point which I wanted to make through this slide. It could be any field. You have carbon-based transistor, it's going to affect robotics. But social distancing technologies, it's going to affect robotics. I am sure you might have seen a lot of robots which are being used in the field, especially during this corona time. Okay, so it's using UV rays to disinfect, and it is approaching the corona patient so that the human being does not get affected. So there is always a lot of applications, new applications which are going to come up, and robotics are going to be there. And any development in any of this emerging technology, that is directly going to affect robotics. So what will a future robot look like? So a future robot, now we are talking about 3D printing, 4D printing, even bioprinting. We are talking about interaction between human and robot. We're talking about cyborgs. Who's a cyborg, right? So a human being with a partial machine attached to it, and there is interaction between the machine and the electrical wires of a machine and the nerves of our human body. Okay, you have sensors, electroencephalogram sensors, which can sense the brain signal. You have electromyosensors, which can sense the electrical sensors from the muscles. Okay, so maybe a future robot it's left to our imagination. Maybe it will be a combination. It will be made up of more advanced materials, or maybe it will be made up of our own human material, or maybe a combination. We don't know. It's going to be. So it's just left to the imagination, right? It keeps changing. We have the robotics companies, for example. I'll just show these companies, right? So these are some of the robotics companies which are working. Okay, mostly in industrial robots and also in other advanced robots, especially KUKA and the Rethink Robotics. This is just we have hundreds of companies, hundreds of hardcore robotic companies are out there. Okay, this is just a few glance. Okay, some old companies and some latest companies I'll just put in this slide. Okay, you can just go to Google and Wikipedia. It has some more than hundreds and hundreds of companies are there, and each company have their own robots, and we have so thousands of robots are there out there. Okay, of different shapes, different sizes for different applications. So it's just left to our imagination. And so talking about the career paths, first of all, you need to develop your skill set in robotics, and then you could either work on an MNC, okay, or a startup. It's up to you. And you can be working in different roles. As you told, it's highly multidisciplinary. You could be from computer science, you could be from mechanical, you could be from electrical electronics, okay, you could be from biomedical, you could be from any field, right? And you definitely have a role to play in the advancement of the robotics. And even for mechanical, you could be working on hardware, you could be a programmer, you could be an installation person, a service person for a robot. And if you're interested in doing research, we have a lot of research agencies all over the world. Okay, even in India, all the government research agencies, they definitely have a robotics division there. It's directly involved. I mean, directly named. You may not have a division called robotics division, but you might have a division which is working under robotics or robotic projects and animation. And you have in academia, you have a lot of universities. So if you're thinking of doing your MS, PhD, you have a lot of universities all over the world. But of course, you need to start somewhere. So you need to develop a fundamental knowledge in robotics and some hands-on knowledge with any of the tool which we just saw. Okay, so that's a starting point. From there, you can expand based on your own, inclination. You can expand to any field. So there's a lot of opportunity, lots of scope is there for everybody. So we need a lot of people out there. At present, actually, this is from 2017. So in 2017, $48 billion US. So that's the robotic market that is there in the world, and I'm sure now it has only gone up. So all these statistics I've taken from McKinsey. So here you can see. So it's predicted that this in 2020, So I'm sure, I don't know whether you're able to see, I'll read it out. 553,000 industrial robots, not just other robots, just industrial robots. Robotic arms have been shipped. And next year, it is estimated to be 630,000 industrial robots. That is, so we need engineers to program them. We need engineers to service them, right? And more companies, as they embrace the Industry 4.0 philosophy, when they're embracing the automation, they are going for industrial robots for various purposes. So it's an upward hill, you can see. And these are some focus by the industry. So they're trying to reduce the cost, increase the quality. Okay, and you can also see they're trying to respond to labor shortage. So there is a labor shortage, and that's what they're trying to respond to. So this is a document by McKinsey. You can just Google it and you can find it out. It has some interesting statistics, and these are some top challenges. So we need engineers to tackle these challenges. Right? We need to come up with low-cost robots. So cost is a major aspect why many of them are not going for robots. Maybe we, engineers, if we are coming up with some low-cost robots, okay, designing and manufacturing low-cost robots, then we can make even the other people use these robots. So these are some roles. You can be a robotic engineer, a programmer, a systems engineer. Systems engineer is somebody who integrates the various aspects that are there. Okay. So as I told you, robotics is multidisciplinary. You have the software aspect, you have the hardware aspect, you have the power aspect. Okay. And in a shop floor, it needs to interact with other robots. It needs to interact with other automated elements like an automated conveyor or automated CNC machine, etc. So we need a systems engineer who can interact everything. We can integrate everything, deal with the data that is flowing, and etc. And of course, you need to install it. Service engineer and simulation engineer is also another field that is there. And application engineer is so this person, he studies the customer's application, and accordingly he suggests the robot, and he also guides them about how to use that robot, etc. And of course, we have the AI/ML engineer. We just talked a lot about it. You can be working in R&D. Even companies have R&D engineers. So you can be working on the latest development of latest material for a robot, a composite material, smart material, or even new mechanisms you can come up with. And if you're after a period of time, if you have a lot of knowledge, a lot of diverse knowledge in robotics, you can always be a freelance consultant. So I've just taken 2 universities which you can go to. So one is the GRASP Lab from University of Pennsylvania, and the next one is from Carnegie Mellon University. So Robotics Institute from Carnegie Mellon University. So I urge you to go to these 2 websites. I have also given the, you can just Google it. So GRASP Lab is from University of Pennsylvania. So they have a huge list of robotic projects that are being done at present. Okay. So if you are somebody who wants to do your MS abroad, okay, or if you want to do a PhD abroad, or even here, okay, you can, even if you're doing it here, you can take inspiration from those universities. But if you're definitely planning to go to these universities, then it's you must have a look at all these projects which they're doing. Okay, many of them are very, very interesting, and you can see. So this is a flying gripper. Okay, so these are just 4 quadcopters, which just they come close together, they can grip something between them. Okay, and you can see the next one. It's a coordination between human and robot when they're moving. 2 human beings can do it, right? They can lift something together. The robot and human being do it. So that's a problem for them. Okay, so looking at all these projects can help you in understanding the problem, how they identify a problem, and how they are working on that problem, and what tools they are using for the problem. And of course, they have also given links to their publications. So the publication, you can just go and you can download the paper, and you can, at least you can just read the abstract of the paper to understand what they do. So if you're somebody who's interested in research, MS and PhD, then these universities, there are many more universities, but these universities definitely you must have a look. These are the reference, some good books, okay, and I urge you to go to this handbook of robotics.org. There's a lot of videos, even some vintage robotics videos also are present in that. Of course, visit these websites, robots.itrp.org.